welcome to another episode of Teaching with Inquiry Live. Tonight we are going to dig deeper into looking at problem solving with math and helping our students solve those word problems that just seem to be tricky for them to solve. So if you have ever had a moment in your classroom where you've had students say things like, I don't understand what this question is asking me. I don't get it. Why do I need to show my work? Or simply they just struggle through the planning and application problems of solving word problems. I have a strategy I'd like to share with you tonight that goes a little bit beyond simply just circling, underlining, and boxing comprehension type ideas in the question and actually moves your students from understanding what's in the question all the way through to justifying your answer. So we don't stop short at just identifying what the question is asking us, but we guide students through the planning, thinking, carrying out, and explaining their answer at the end. So if you're new to the show, this is Teaching with Inquiry Live, and I'm Patty. I am a 4-5 split grade teacher here in Ontario. I'm also the teacher blogger behind madlylearning.com, and every Monday night I go live and we talk about all things related to teaching with inquiry in our classrooms through this show, Teaching with Inquiry Live. So thanks so much for joining me. I'm happy that you have joined me tonight. So welcome to those of you that are here in the show. And you can give a little hi and say hey and let me know that you're here. Thanks so much for joining us. So to get started, one of the reasons that I was struggling with my students to get them to problem solve started probably, well, let's be honest, struggling with problem solving word problems is an ongoing issue with students. But one of the problems that they were having was that in a word problem, the math isn't explicit. So if I was giving them questions that would just be two numbers stacked on top of one another, and I would give them the operation that they were using, generally speaking, they could use some of the strategies in place. Throw that same question in the context of a word or story problem, and it got a little bit more difficult. Add in a multi-step problem where students had to either take out the parts of the problem that didn't make sense, or they then had to also look at some of the problem and figure out there were multi-steps that needed to be solved before they could finally arrive at the answer. That became increasingly difficult. And I was growing frustrated with the problem-solving process acronyms that were out there because what I found is that they were simply just allowing students to decode what the question was asking them. It was also leading them to a very formulaic expectation of what a word problem was like and how it would be structured. And what was happening is that wasn't transferring into different contexts. So if they were solving a real world problem or came across a question that wasn't set out in that same format, they were struggling. Or even worse is when one of our words that we typically associate with, say, addition, if that word showed up, those key words showed up in a problem, yet the operation to be used wasn't actually addition, it became a big issue. Students weren't becoming resilient with solving problems. So I set out to come up with a different acronym or to find a different acronym that would help my students go from understanding the question through the thinking and planning process to solving the problem using a variety of strategies and then finally justifying their thinking. So I came up with the acronym of CHASE. And I'm going to go through those 5 different steps for you tonight and walk you through how students can use this acronym to help them go through this problem solving process. So the first step is similar in the old traditional strategies that are very popular to be using. Students do need to understand exactly what the question is asking them to do. They need to define the problem. So one of the things that I like to get students to do is to highlight or circle and identify what the problem is that's supposed to be solved. What is the unknown that you need to figure out? What is that problem? Often identifying that problem in the word problem is important. Sometimes I like to throw a wrench in there and not always put the question in a word problem right at the end where they expect it, but to put the question in different locations in the problem, because in reality, the problem we're trying to solve doesn't always come out at the end of the problem that we're given. So that is the very first step. The next step in the problem solving process is to hunt for the clues. Now, for this, they have to look inside the text and identify what they know as well as what they don't know. And I prefer to get students to actually list this out as opposed to simply just boxing it or underlining it. I want them to list it out because I think it does help them later on as they're coming up with a plan to take all of the unnecessary pieces of the story problem out, ignore that, and just look at the facts. So if you have a problem where Jessica goes to the store and buys a teddy bear for $3.50 and buys a board game for $8.26, how much does she spend altogether? So if students were to take that out, they would write teddy bear, $3.50, board game, $8.26. That gets rid of all of those unnecessary words that they don't necessarily need to know. And because they've circled the question, they need to know how much did she spend altogether. So they're listing out those clues that are necessary for them to understand what is the numbers in the math that I know and what is it that I need to know in order to solve this problem. And that leads to the third step, which is assembling a plan. Now, this is where we go beyond, say, a traditional circle, box, underline, solve the problem type of strategy, because you really want students to be problem solving and applying what they know about math into choosing an operation that would be appropriate for this plan, as well as coming up with the plan of action for what it is they need to do first, second, and third. Now, I will share with you that recently I had an aha moment, and this came into looking at the achievement chart and how it relates to math. In particular, looking at the difference between thinking and application and how it's assessed specifically in a word problem. And the aha moment was this. Application in a word problem is where the operation for students is not given and they have to identify what operation is best used in order to solve the problem. So in the example I gave you with Jessica buying the teddy bear and the game board, students in that would be an application question because they simply just have to put two things together and add it. Their challenge with that is to identify that addition is the operation that's required to solve that problem. It's a one-step problem. Compare that to thinking, which is the next part of that achievement chart that we are often using here in Ontario, and I know that that's embedded in other assessments, is looking at the difference between a student's application and their thinking. The thinking is coming up with a plan and carrying it out. Now, this is more relevant if you have a multi-step problem, because not only do students have to choose the appropriate operation, but they also have to identify what needs to be done first and what needs to be done second, and so on. So that's where you assess thinking. So if we took a problem such as the Jessica buying a teddy bear and a board game, and we added in, now if Jessica paid for this with a $20 bill, how much change would she have left over? Now I'm adding multi-steps to this problem, and therefore students will need to decide what do they need to do first. There's multiple ways that they could get to the answer, but they will need to decide what they do first and what did they do second. So students could choose that they first are going to add the two objects' prices together to get a total, and then they need to subtract that total from the $20 bill. Or they can start at the $20 bill, first subtract, say, the object of the teddy bear's value and then subtract the game board. There's multiple ways that they can approach it, but they have to come up with that plan. What is it that they're going to do? Now, this assemble a plan is the hardest part for students because they look at problems, especially multi-step problems, and they think that the math is going to be simple, where they're just choosing one operation, and they think that they can solve the entire problem all at once, and they get frustrated because it's simply not possible, because it's more than a one-step problem. They have to go to 2 steps and beyond. So I often like to use the analogy of having a pool party with my students, and I ask them, if you were having a pool party, would you grab your sandwich and jump in the pool? And they look at me strange because it kind of grosses them out, because they know immediately that if they jumped into a pool with a sandwich, their sandwich would get soggy and it would be just a mess, and not they would be hungry and they couldn't go swimming anymore because the pool would be filled with gross stuff. So students often get that. Of course I wouldn't jump in the pool while holding my sandwich. And I say, okay, well then what would you do at a pool party? Well, first I'd eat my sandwich and then I'd jump in the pool. I said, aha. That's the key. This type of math problem requires you to not just do everything all at once, but to decide what operation are you going to do first, then what are you going to do next. There's steps that is going to be involved in this, and that is a key for getting students to make a plan of action, which you're assessing their thinking skills, not necessarily their application skills, because you want them to be able to make a plan to solve their problem. Even if that plan is simply, I will just add those 2 numbers together, or if it's, I will add those 2 numbers together, then I will subtract it from the total money that they had spent. Coming up with a series of steps is a key here in this problem solving strategy, because you really want students to be thinking before they begin solving it. They need to explicitly think, what can I do to solve this problem? So sometimes for this step, I also like to get students, I give them perhaps sentence stems or sentence starters that are in the form of questions that they can ask themselves when they're assessing a problem and determining that plan that they're coming up with. Questions such as, what is this problem asking me? What operation might I need to do? What should I do first? What should I do next? What is the problem I'm trying to solve? These are all things that they should be able to answer with the question. Once they have that understanding of the story and an understanding of what needs to be done first, second, and so on, then they need to begin to solve the problem. Now, in this step, this is where the dreaded show your work comes into play, that students often don't understand why it is that they need to show their work, especially if they can do that work in your head. So for this reason, I've actually switched what I'm asking students to do this year from please show your work to please make your thinking visible. This seems to change the idea that, well, I didn't do work because I did it in my head, and that's different than make your thinking visible, meaning whatever thinking you were doing, whether it was on your head or with manipulatives or on paper, you need to somehow make it relevant to your reader and explain what you were doing, whether you're doing that with the work right on the page, whether you're taking pictures of the manipulatives as you're using it, or whether you're writing out the steps that you did in your head. It's making your thinking visible so that the person looking at your work understands how you arrived at the problem, as well as where mistakes were possibly made. So I'm really liking that shift in how I'm asking students to show their work. Instead of saying show your work, I'm using the make your thinking visible, and that is, I'm getting a little bit less pushback because they're understanding that I'm not necessarily expecting them to write it all in one way or to put work on paper if they're doing it in their head. All I'm asking is for somehow to make their thinking visible on the paper so that I can understand how they've done that. And they seem to be more open to that phraseology than the show your work. With the solve the problem, you also need to list and give strategies for students so that they can come up with different types of things that they can do to solve the problem. Things like, I can use algorithms, I can use my different addition, subtraction, multiplication, and division strategies. Things like repeated addition, number lines. I can use charts and graphs and tables. I can use manipulatives and calculators. All of those materials that students can gather is important to list there so that they can get used to that there's more than one way to be able to solve a problem on the paper, that it's not always a standard algorithm. Perhaps if they don't really understand why the standard algorithm is working, that might not be the best way to make their thinking visible. They could do that with some manipulatives, or they could do that by writing it out, or they could do that by making a chart or a table. These are all strategies that could be used, and listing those as students are using them and as you go through them with your students. So as you're teaching new strategies, you can add that to an anchor chart of all the possible strategies that they can use for this step of solve the problem. And then it gives students a framework that when they do encounter future problems, they can reference that anchor chart and say, okay, it's more than just pictures, numbers, and words. It's beyond that. I can use charts and graphs and tables and manipulatives, and I can use numbers and words and algorithms and number lines and rulers and calculators. There's lots of different ways that I could attack this problem using different things, and we all have a reference because as we use them in our class, we can add them to that anchor chart that might be near our math board. Finally, the last piece is where you can assess that communication part of math. It's where you can decide whether or not students have understood the question, whether they have made their thinking visible, and they've been able to explain it in a way that makes sense to others, is they can justify their answer or explain their answer. Now, I do always try to get my students to explain their answer by using the information in the story problem, because if the question is about Jessica, then their explanation of their answer should also be about Jessica and the toys she bought. It simply shouldn't just say, I added $3.50 and $8.26 and I got my answer. I want the answer in the relation to the story problem. So if it's about teddy bears and Jessica and board games, then that's what their justification should be as well. It should somehow allude to the operation that they chose if it's not always obvious above, or they haven't used labels or made their thinking explicitly visible above. I do want them to add more detail. So the more of the math they're doing in their head, the more detailed their explanation of their answer should be, because that's another way that they can communicate their knowledge about math in a word problem. So those are the 5 steps of this problem solving strategy. And as you can see, it really does walk you through all of those processes. And by looking at students as they go through this process, you are able to collect a whole host of data, from knowledge and understanding to actually using operations appropriately, to choosing the correct operation in a word problem, to using thinking skills and planning skills by making a plan, and communication skills as they are communicating their thinking, making their thinking visible, and justifying the answer to the word problem. This is one of the reasons why I wanted a strategy that didn't just stop at the comprehension of the question, but that pushed students beyond to actually solving the problem, not just understanding and comprehending the problem. So thank you so much for joining me. If you want to have these posters and the strategy more explicitly, including different things for students like posters, anchor charts, cards for their math notebook to use, bookmarks for them as well, all of that is available on my TPT store, and students can use that. There's also a scaffolded support for students to walk them through all of the different steps while they're answering a problem as they're getting used to this strategy, as well as a little flip book. There's lots of things that students can use there, and you can find that all on my TPT store. The link to that is in the blog post. So if you hop on over to www.madlylearning.com, you are going to see a detailed description of all of these 5 steps, as well as the link to the resource for this so that you can get your hands on this poster pack as well. And that is what I have for you. So I'm really hoping that this is a different strategy that will help push your students not just to understand the question, but really push them through the entire problem solving model and help your students to come up with strategies that will allow them to be successful problem solvers in all different types of math problems. Dawn, thank you so much for about making your thinking visible. That's just something that I've introduced this year. I heard it last year at a conference in another context, and I really liked its application into problem solving, because it's less about just showing their work, because they didn't actually do any work. So that's the big fight. Same with whenever I ask a reflection question that asks students to, what did you learn about this? And they're like, well, I didn't learn anything. Okay, but that's not really what I'm asking you. Trying to really be clear about what I want students to do. And I'm finding that they are really understanding this phraseology much better when it comes to problem solving. So we've just added the link there to the Chase resource right there in the comments, so you can hop on over and grab that. But even if you don't grab it, you can make it yourself. Use the acronym and the information on the blog post, and you can go ahead and use that all on your own. So thank you so much for joining me and for sticking with me every single week. And next week will be our last episode for the year, and then we'll come back in the new year once school resumes. We'll take a little hiatus over the holiday break, but we will be back in the new year. So next week is our last episode of 2018, and then we'll be back in the new year. And I have a few things up my sleeve for next week, so stay tuned. I think it will be an episode you will definitely not want to miss. So thanks so much for joining me. I hope this was a helpful tip and strategy for you to use in your math. I will talk to you very soon. See you next week. Bye for now.